The experiment you're going to see relates to the several seismic tests carried out at the laboratory of Perugia Engineering University on one prototype realized by the M2 technology. The prototype reproduces a two-story building in its actual size, being 4.2 for 3.5 meters on plan and an eaves height greater than 5.6 meters. For vertical walls and floors were used respectively PSM 80 and PSS 80 panels without additional reinforcement. Vertical panels were connected to the foundation realized by PSM 80 panels through the use of our angular meshes, generally used for connecting the panels in correspondence of the junctions. A staircase was placed on one side to connect the two floors. The successive phases of work have given to the building the look you see. The earthquake action was simulated through the excitations produced by one mechanical exciter able to generate horizontal thrusts with variable frequency and magnitude. The structure behaves as an oscillator endued with a known vibration period and submitted to impelling cyclical forces. 3 series of tests were carried out on the prototype, each series with a duration notably longer than a normal seismic event. For the first series of tests, the mechanical exciter was placed on a level with the first floor, where it was concentrated most of the seismic load, giving to the structure a maximum acceleration of 5 meters by square seconds and transmitting a maximum load of approximately 2000 decanewton, which is the ultimate load reachable by the machine, for a duration of 80 seconds and ranging with continuity on the whole frequency spectrum up to the maximum frequency reached, result to be equal to 21 Hz. The maximum displacement noticed by the laser vibrometers on a level with the first floor resulted to be equal to 0.13 mm. For the second series of tests, the mechanical exciter was placed on the covering floor on level with the roof ridge. Considering the static scheme of the building, which behaves as a shelf, such a position corresponds to one able to produce the greatest dynamic effects with a maximum load of 2000 decanewton. Accelerations of 9 meters by square seconds were noted with maximum displacement equal to 0.4 mm, always on a level with the first floor. In order to test the prototype under the most severe conditions, it was decided to carry out the third series of tests with the mechanical exciter placed on a level with the eaves, on the side adjacent to the staircase. Indeed, the structure, because of the presence of the staircase, shows an asymmetrical configuration that, submitted to the horizontal actions, generates some twisting stresses. During this third series of tests, accelerations of about 10 meters by square second were noted when reaching the resonance frequency as in the previous cases. The maximum displacement noted on a level with the first floor were about of 0.3 mm. Considering the weight of the building equal to 170 kN and the weight of the global seismic loads, it can be gathered that the force through which the structure was stressed was higher than one expected from a seismic event